Alright, hello everyone, welcome back. It is good to be back with another one of these CodeChef competitions. And it should be starting in about very shortly. Okay, let's start this. So we got 5 problems for this. Let's see, will they load up on the Safari browser this time? Oh good, they are. So 7 is lucky, 7th letter is going to be considered lucky. And you're given string S. Line 10, what is the lucky letter? Oh, okay. And just go S equals input. Actually, can we one-line this? This feels like it's possible to do in one line. I don't know if this is actually allowed, but we can see. Oh, look, it is allowed. Just take the input and then so thus we have our Python code golf solution. There we go, very nice. Okay, on to our next problem. 12, okay. 12. And let's see, so we're playing a certain video game. We have to collect monsters, fight other monsters. Stat X, H. Okay, how many turns? Easy enough. Let me see, where's my okay, so if 5 times x divided by 2 is less than or equal, is greater than or equal to h, it will take at most 5 turns. Then how do we compute this? It'll be h divided by x2, and then we need to do a ceiling division, because like if we do like 10 damage per day, then anything from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 will be allowed. 0 will do 0 damage. So what we actually want to do here is x divided by 2, subtract 1. This sort of thing is the general rule for ceiling division. And then we can do a similar thing here. V plus x damage minus 1 divided x, and then print answer. Alright, nice. Also, they did change the grading system. This now says correct instead of AC. $6.21. Start mixing extraordinaire. So we have n distinct juices. Our input will be for I in range readint, and then read array. So they're different if the drinks are different or the quantities are different. Okay, so just to confirm here, something like 1 ml of X and 2 ml of Y is different from 2 ml of X, 4 ml of Y. The first test case gives 11 times 7. Okay, we note there's at most 1000. 1 times 3 is 3. 1 times 5. And then 3 times 5. 15, 20, 23. Okay, answer is 0 for A in range n minus 1, for B in range from A plus 1 to n. Answer plus equals you just choose the 2 drinks and then it's the number of choices you have for their quantities. Now if the same ratios were considered equal, that would be, that would make this much more complicated. But I think we should be good here. Okay, nice. So this brings us to GCD discount. Let's look at the input first. It's n readint AR read AR BR is read AR. Okay, so price of, so we have AR with the prices, BR is the discounted if you use the coupon there. You have 1 coupon. You're given several entries in a raffle. You get some number of entries equal to the GCD. prices of the items are 9, 18. Okay, what is our values? Our values can go up to 100 million. If there's a way we can test each one fast enough. Okay, I think I might have an idea. So first we can just do a basic GCD here just to make this easier. And then we'll do a two-way DP. For j in range, and -1, take the last element from front and then get the next one, which would be arj plus 1. So we're taking the GCD as we go from left to right in the array and right to left in the array. So we now know the GCDs of the first however many elements we want and last however many elements we want. And we want this as high as possible. So our initial will be just what happens if we take every element. Without using the discount. For k in range. Then we have n ways to use the discount, but I'm actually going to start from 1 to n minus 1. Just to handle the first and last cases separately here. So if we discount the first one, it will be the last n minus 1 elements. Currently we have 1, 2. This should give the second last value, so n minus 1. And then we need the first one. If we discount the last one, it is also okay, and then now we have to do k in range. So how many elements in front do we take? We take front k minus 1, I think. So in the first case, we take the second element, so we only need the first element. First element stored in index 0. Yeah, that should be about right. And brk. And then back is a little bit trickier. But what I think it is Okay, so n minus 1 contains all of them. N 2, n minus 3, I think. I think that's what it is, right? If we have 3 elements, then that should bring us to 0 for this index. Yeah, my real concern here is I'm not sure if I'm accessing like invalid indices. I don't think I am, but... And also these should be maximum. We're aiming to make this as high as possible. Okay, make sure we're doing the GCD operation. Okay, that looks more accurate. And we have something a little bit off here. Okay, so that is at least correct that we don't need to use the discount. Okay, and okay, what is happening here? Taking our discounts here. Let me see, what is our... Okay, yeah, I got correct on the first one and then wrong answer afterwards. Hold up, what happens if we have a test case of 1? I mean, it has to be a lower value. Okay, yeah, there's something that goes on with 1. Can we get 1? We can have 2. Okay, we need to make sure 2 is working correctly. I mean, 2 seems to be working fine. Okay, just to make that was just to make sure. Okay, to make this easier, we could do 0. We could be inputting 0 here instead. So then for j in range to n, so then the index is now just the number of elements that we're actually using here. Can do n. This always makes the indices a lot easier to track. Still get 4, 17, and 10. Okay. I mean, this does fix if there was any indexing errors. I don't think there was. Okay, maybe there was, actually. Yeah, I might have done some weird indexing error earlier. But okay, that's good. We got this problem a bit later than expected, but we're doing pretty good. Now we can go to the final question, which might be difficult, but we'll give it a shot. We got a piece of land. We want to build a house. One side borders the forest, so you build a fence. You need fence posts. You will place n distinct points. What's the longest empty segment along the border? Oh, one at a time. The item will be placed at point X there. So we got 0 to 5. Then we place one at 2. Then we place one at 4. Okay, this is a little bit. This is definitely an interesting problem. We can take the maximum of a set, right? Okay, where's the documentation for this? Usually I don't use sets, so I mean. Okay, let's do set dot. Is there set dot add? Python set. Oh, okay, never mind. Of A. Okay, and then second question. Can we do something like this? So like suppose this is all length, and then we have 2 to 9. A dot add 202 A dot add 7 10 6 17. Okay, yeah, they are doing the gaps between posts. So you got A. Can you take the maximum here? Yes, you can take the maximum. So then the first value will give you your max. Now I think this is remove. And then this could be replaced with something like a shorter value. And you can imagine there. Maximum A now, 7. Oh, okay. Okay, I think I see where this is going. Okay, now the next part we need is being able to track which segment it's in quickly. So how do we track what segment this is in fast enough? Wait a second. Actually, wait, the set structure has its own problems. Since if we're calling this 200,000 times and it's linear time, then we're basically doing a quadratic calculation. So we have like two parts, which is we have to determine what segment the fence post will end up splitting, and then we also have to determine if the above would affect maximum length. So we could use two binary search trees. One to keep track of the segments, and then another one actually for tracking the start point. So then we can use another. And lastly, we have a dictionary of some sort. Start point of each segment to end point of every segment. Now the issue here is that we need a binary search tree. This is where we would call upon the usage of the red-black tree. What is NM and then then for J and AR, what's the steps? And we just do a print star answer. Okay, and now we need to find a red-black tree template, because implementing a red-black tree is yeah, no. In C++, there is a easier way to do the binary search tree and keep it balanced. Python, this is one of the few actual weaknesses. Okay, so red black tree, and then there we go. Okay, so this is our red black tree template. If we do this correctly, everything will exist. So ordinary binary search insertion. Okay, so we initialize this node with this tree with a very, very large negative value. If we think about it, our indices are all going to start at 0 and our length has to be at least some value, so I don't think this should affect it. So factory K insert, fix insert. Okay, and then find is find was doing minimum distance before this here. So now just above. So find self root x. So x is, what would x be in this case? X is the post boundary that we're doing. So if x root dot value I think I set y to be root dot value. If x is greater than if y is greater than x somehow, then that means our middle current point is then we need to go lower, and since we always have 0, we can always go lower. So self root dot left no, this is root dot left, and find x. So otherwise y is a valid point. That means anything on the left child can't be possible. Check right. Now, if it does not have a then just return y. Otherwise, we do have a right child. Okay, well, there's a thing here. If we have the middle, let's say the middle is actually our hit point. Like, that's the best we can do. Then if we go right, then everything on that tree would fail. So we need a dummy value here. So let's, if root dot left equals none, then this is an all fail. Return something like that. Otherwise, we try going to the left. if we do not have a right child, then we definitely can't do any better. Otherwise, we return the minimum of y and find root dot right. Okay, now all we need is wait a second. Wait, how do I remove notes? This? Oh, bloody hell. Okay, screw this. We're using a new red black tree template. Because this one apparently doesn't know how to delete. Okay, yeah, this might be a little. Alright then, so yeah, this is a problem. Speaking of which, how many people are... Oh wow, almost everyone's like... Am I overthinking this to all hell? I feel like I'm overthinking this again. I mean, it is a hard problem, but like, seriously. insert this. Well, and then there is delete node. Where's delete node? Okay, so define Jesus Christ. Find so we'll do the same find here. How is this going here? Y is greater than X, then we need to try left boundary. If there isn't one, then just return there. Otherwise, if there's nothing there, then return Y. Else, return maximum between current Y as our passing and self.find r.write X. Just keep going higher and higher and higher. Return whatever A's value is. Okay, now we need to starts equals arbitrary. Initially, our only start is at 0. So just insert the 0 node. we'll make a blanks RB tree. It goes 0 to m, so m, and then d0 equals m for our dictionary. Okay. I think we should be getting close here. Now, L equals starts.find starts.root, and we need j, so we need to our right boundary is dl. Okay, so now we need to remove node or delete. R minus L. So DL is now J, and we insert a new segment at J to R. So that means we do lengths dot insert J minus L and then R minus J for the two lengths. And there's one more thing as well. We need to insert our new starting point in J. And then lastly, answer dot and lengths dot whatever our largest length is, and then return. Okay, so how are we blowing up here? Nil, 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 and nil. Okay. Okay. It starts so 0 and 2. Lengths are 2 and 3. 204. The only thing I can think of is that we're getting empty weaves at the end here. Because sometimes I think with red black trees, some of the implementations use like no weaves at the end. 3, 2, 4, 3, 2, 1, 15, 13, 13, 7. That looks about right. And now we can try and see if this is correct for E. 332 line program. I mean, at this point I'm more concerned that okay, and there's a runtime error, of course there is. I mean, it's just going to be more ChatGPT. Okie dokie then. So we don't think the under insert.
Good morning.
Yeah.
Is it faster if I drive you to Metro Town, you go to UBC, or same distance?
Let me see.
Because like I'm going to go to Metro Town area, I can drop you.
Okay. Let me. What time are you going to Metro Town?
Oh, I can just make sure. You want to go at 7?
Oh, I'm going later than 10 for sure.
What? 11?
Yeah.
I'm okay to do that.
Yeah, sure. Yeah, I think you can. Yeah, I think we can just go to Metro Town. There's a bus that goes from there to UBC.
Yeah, directly.
Yeah.
And then, what is it? Oh, later before you sit down, garbage.
Okay, so what is going on here? don't think we can get any actual runtime errors going on here. Yeah, this is one of the few things I could think of. Like, this is pretty much, I mean, it's kind of ugly, but okay, it's not that either. Okay, what about the absolute? Then we try the simplest case possible. 1, 1, 2, and we place it at 1. Gives 1. It's distinct. There's at most 200,000 posts being placed. Okay, I'm going to change this to -1 because something seems to be off here. We can reasonably have nodes of values. We started off with a node of 0, so maybe it's this. It's not that either. The underscores are not placeholders. Modules are already implemented. That's already done. Okay, well, now we're just going into full degen. Yep, we're officially in full degen mode here to try and figure this out. Search tree helper, delete fix, insert print helper pre. So let's first see what's going on here. So this is now being called a red-black tree like this. Tino, okay. So yeah, I do throw the root back. So now this is probably T. No, we're calling this item now. Maybe it is this. If left is a no or right is a no. Okay, let's see how this. Where's item? $378. Okay, now what the hell's going on? How are we still getting runtime errors? Okay, you know what, screw this, we're using sets. Do I really know how to code in C++? Not really, but I've seen enough templates that... And this is an unranked contest anyway, so... If there's any time for me to try, it may as well be now. Okay, well, this is going to get incredibly scuffed. Okay, so we might need this. This usually is useful. And just define the type definitions. I don't know what this does, but this is just helpful for input, I'm pretty sure. Seeing something like this. Vector LL, we have n elements, and just do something like 0, I think. Find rep IAB for okay. And take a value, put it in ARI. Okay, now we have to figure out how the hell do we use sets. And let's just do a quick compare here. So set start, set lengths. Set lengths. Just put this here first. Insert 0. Lengths. Insert n. Okay, C++ dictionary. There's 4 ways of making a dictionary. It's probably unordered map, right? How the heck does this work? Okay, never mind. Let's use the login map. This feels safer. We're using namespace std, so I think we can just do something like this. Then we got d0 equals n. Rep j promote n for all the values in the array. while mass will greater than 1. C++ does integer division by default, right? If it is greater than if it's too high, it's wait, if our starting position is here, we need otherwise low becomes mid. We know low will always work. L equals low if or no, it starts at least starts high. Equals DL that methods How do I erase correctly here? see. Modifiers. So we get wait, now we're not even tracking duplicates. What the heck? We get one here. LC is M for ranked M. Three L's will be the length of our segment. Get DL. Then what? So then blank count of LLL. If this is 0, then dot erase LLL. Then J equals R. Does a key exist in the mappers? It's logarithmic apparently. If lc.count a is 0, ca equals 0, ca is plus, points then we just do the same thing with b. Starts dot insert j. Print last. points. Length of set is repeat here, see out. Okay. Yeah, so how fast is this going to implode? So what did it do again? Okay, mid is not declared in the scope. Yeah, that's my bad. Oh, I meant to use ordered set. God, bloody hell. And then what else is there? Yeah, I also completely forgot semicolon here. See. Okay, yeah, we may as well just try looking at how I was doing this earlier. Okay, just run here. Yeah, I have 3 minutes to figure this out. Okay, remind me, what was the problem again? We have a runtime error here, and then yeah, the only other change I could see right now is in prefixing. like you can use a frequency array to check the links, and then you know which links are actually in there or not in there. Probably ended up going on. Also, technically the contest already finished. Yeah, this problem is this is some sort of problem. JLRJ. That part's fine, and then pretty much my problem is how the absolute frick do you do binary self-balancing binary search tree properly here? Literally just that, and I solved this. Yeah, might post an update later on this question, because this is, yeah, I have some, yeah, this is just ugly. This is very ugly. Well, the good thing is this is not actually rated, so that's also partially why I did attempt that C++ experimentation, even though I really do not know what the heck I'm doing with that. And next Wednesday will actually be Starters 100, which will actually be rated, and it will be the 100 Starters contest. Hopefully that one goes better, and yeah, I think I'm just gonna finish it here. Okay, bye now. I'll be back Wednesday or something.